first we have a brief introduction to this webinar where we set the scene. Then we go into advanced scheduling. So we want to have a common understanding for everyone. What is it about and what are the common techniques? And then we dive into a real life client case. That will be my colleague Piero, who will explain how we as a FESO tackled such a case at a client. And at the end, as mentioned, there's a Q&A. Good. So maybe a first introduction. My name is Thomas Snijder. I'm a data analytics consultant at FESO. I have about 5 years of experience working with data science, AI, and so on. And here at FESO, I've worked mainly on projects where we combine data analytics with operational excellence. Piero, maybe a quick word from you.
Yes, thank you, Thomas. I'm Piero Donaggio. I am currently the CTO and the head of data science practice at Fibonacci Lab, who is the digital division of FESO. And I've been in this industry since more than 15 years, building products and AI solutions for many different industries.
Yeah, thank you very much. All right. Just to give a view, so this is the third webinar we organized within our Operational Excellence Powered by Digital series. So a series of webinar where we showcase where digital solutions can really elevate your operational excellence efforts. In June, we talked about predictive maintenance. 2 months ago, we talked about process analytics, and today we will talk about the scheduling and digital enhanced scheduling. In February, there's also a last webinar of this series where we'll talk about energy efficiency and transition projects. So that's really where we go from a walkthrough all the way through implementation, finding opportunities to boost your energy efficiency and basically reduce your energy waste. Good. So maybe to set the scene for this webinar, so we have 3 goals. First, we want to make sure that everybody gets the same view of the benefits of advanced scheduling. Then we go into a few requirements for the common technique, so what you need to have or need to do to implement it, and then we go to a FESO approach where we walk through a client case and say how we combine it with operational excellence. Maybe first we would like to have a small feedback from you, so please take out your mobile phone. And please go to menti.com using the access code or just scan the QR code where I would like to have a little quiz. So yes, I see people are already filling it in. So the first question is, what challenges in scheduling are you facing mainly? So can I schedule all my orders in time, or do I have to incorporate certain delays? Can I find an optimal allocation to my equipment? For example, there are multiple ways of producing something. The optimum, is it only in silos for specific parts, or is it an optimum for the whole site? Are there a lot of changes during the day? I see that one is winning the race currently. So do I have to adjust my schedule many different times? Scheduling efforts take a lot of time. Is it very labor intensive? So we have 9, 10 respondents already. That's good. So we see that mainly it's the changes in the schedule that happen a lot, combined with either it taking a lot of time or really finding an optimum that works for the whole site. Good. Then we go to the next question. So if we define a schedule, which target or which KPI am I looking at to say, okay, this is my best schedule? Is it, for example, my customer satisfaction on time delivery? Is it my machine utilization, OEE, for example? Are we really looking to have the most output or reduce the costs as much as possible? Or perhaps are we already looking at optimizing our energy usage? So we see a nice spread. We have winning the machine utilization, but also the on-time delivery and the cost. That's clear. Good, very interesting. You see parts of it will come back during this webinar. Thanks for your response. Good. Now let's dive into the world of advanced scheduling. So let's start with the basics. What are we trying to improve in our scheduling? You could have your operations manager who is asking for a better production capacity. Can we produce more? Can we use our machinery more efficient? For example, if demand is higher than production of a current day. But we can also have a customer service officer asking, okay, what's now the best delivery date we can offer for our customer? So what we're trying to do is really finding the best allocation of jobs of our production to the machines in the current environment. And that's, of course, in the past year or years, there's been a lot of disruptions in the market, a lot of uncertainties, which are blocking our ways to finding an optimum schedule. Many times you could have supply chain issues or yeah, with the war and everything that's happening, it's really impeding our ways to find an optimum. So how can digital help here? So that's the concept of advanced scheduling. We call it, it's the optimization of your scheduling efforts enabled through digital solutions. So how does that work? Let's look at it conceptually. On the one hand, you have your constraints. So you have certain resources available. This can be either machines or workers. You have a certain demand that you need to be able to comply to. Of course, each production process has its own operating constraints. For example, certain batches cannot follow each other or certain products. The workers themselves, they also have their personal constraints. You have work hours you have to take into account. There are holidays and so on. You have to reach certain KPI targets set by the business objective. Either way, there are a lot of constraints you have to take into account when you are making your schedule. Now, on the other hand, you have a target. Either you want to minimize your cost or you want to maximize your output. Or as we've seen, we want to have the highest customer satisfaction. We want to boost the OTIF. We want to have our machines always running at the highest OEE. Or even now with the energy crisis, we want to be smart with our energy usage and optimize that as much as possible. So these optimization targets, they're really the goal. What are we trying to improve? It can be one or it can be multiple. Now, as a scheduler, you're trying to find a schedule that fits all the constraints on the one side and then has the optimal for your goal. Now, through a data-driven and automated calculation using algorithms or digital solutions, we can actually boost our capability of finding this optimal schedule. Because in reality, yeah, there are millions or billions of different schedules that could work, but how do you find the best one? And by using a digital solution, it's much easier and faster to find actually the best way to schedule your operations. So if you look at an example, here we have a simulation where we evaluate many different scenarios, and each dot represents basically the outcome of a certain schedule. As you can see, there are 15 trillion cases for this scenario that are possible, and our algorithm will evaluate not each and every one of them, because that's what makes an algorithm good. It's not doing all 15 trillion, but really looking, okay, which ones do I really need to look into that could potentially be better than our initial plan that we have put forward. And over time, as you let the algorithm run, you see the red dots appearing, and these are the optimal solutions, which are actually the best schedules that it can suggest. And here you have two different KPIs that we want to improve, lead time and holding stock cost. And you see there's a trade-off possible along the red line. So that's the Pareto of possible solutions that the algorithm suggests. Now, what does this mean in real life? So we've looked at a few results where we have successfully implemented advanced scheduling at our clients. So the first thing is really to boost your operational performance. That is to increase your production capacity or to increase your OEE or equipment saturation. So here we've seen that we can realize at this client that we worked 9.5% more capacity or 5% OEE. On the other hand, you can also express it as a saving. So instead of investing in new equipment, finding a better schedule could actually save you from investing in expanding your production line and just making use of your production capacity smarter. On the other side, of course, we were also looking to improve the on-time deliveries at our customers. So can we find a better delivery date, or can we adhere to this very strict delivery date? So we boosted the customer OTIF with 8%. And lastly, the resilience of able to be more resilient to changes and disruptions from outside is really enhanced by having a digital solution that runs maybe 10 times faster than a manual scheduling effort. That in 30 minutes or less, you can find a new optimal schedule. This will really help you if you say that your schedule changes a lot during the day. If you could, at the touch of one button, find a new schedule in a reasonable amount of time, that's again the optimum. So really boosting your operational performance, potential savings on investments by making smarter use of your equipment now, boosting your customer satisfaction, and really being more resilient to changes are the outcomes we want to highlight. Now let's look at a few techniques or algorithms that are used in advanced scheduling. So we have here 3 that we wanted to highlight. So we had 2 more algorithmic ones, the mathematical optimization and the constraint programming, where it's really an algorithm that looks for the best schedule. And then the third one is a digital twin, which is more a solution, so to say. So the first thing is mathematical optimization. That's the oldest one in the book. It's really defining your problem as a mathematical problem, like you did in high school. So with a limited set of constraints, you try to find the optimum and the best solution that works. The algorithm is called mixed integer linear programming, and it was actually invented at the end of the Second World War when the US Air Force had the Berlin Bridge. So they were supplying food and other resources to Berlin in West Germany. And they needed a way to schedule the flights that were leaving every 5 minutes, I think, to optimize the planning of that. So for that, they invented this linear programming algorithm, and it's actually still very reliable today because it's a mathematical solution, and it finds the best solution. But of course, you need to make a few simplifications to make it work. That's why, it's good speed-wise, but it cannot handle maybe all the constraints that are in your production process, or if you have a very complex interconnected production line, it might not be the best solution. This is really, if you want to look, for example, on one machine and you need to schedule 10 or 20 jobs, what's the best solution? There you can use mathematical optimization. Going a step further is then the constraint programming, and those are the more state-of-the-art or more modern algorithms that help you find an optimum. So what it does is it takes all the constraints that you have, and then it can really be a large range of constraints, and it looks at the objective or multiple objectives you want to optimize, and it will find a solution that satisfies all these constraints. And the way it does it is, like we have seen in the simulation earlier, it will consider all possible schedules that fit the constraints. Might be 15 trillion, like we saw on the right, but by intelligently selecting the ones that can potentially be better than an initial solution, it reduces the number of schedules it needs to evaluate, making it more performant and more speedy. The algorithm we used in the example here was called a meta-heuristic optimization model or algorithm. And basically what it does is it makes a few assumptions about the constraints. For example, the lead time needs to be around a certain amount of days, and it will start from that position and try to improve as it goes along. Meaning that the speed might be a little bit less than what we saw at the mathematical optimization, but it can really handle all of your constraints in a very complex production line. Implementation is also quite fast because these algorithms are just available open source, and we know how to do that quite well. Well, if you have specialized software, then you really need to think, okay, is the cost of implementing worth it, because every production line is different, and the specialized software might not always be able to find all the details or incorporate all the details in the model. Now, and the last one is a digital twin. So for those who don't know, a digital twin is basically creating a digital copy of your production process in a simulation software. So that allows you to really run scenarios through the simulation and test the outcome without really doing it yourself. So that's why it's a digital twin. Now you can also use a digital twin to basically find which schedule works best. So if you have a list of possible schedules you want to try out, you can make a digital twin of your production line and then define which KPIs or which objectives you want to measure at the end of your production, and then run it through the digital twin and then determining which one works best. Now, as you can imagine, this might not be as fast as the previous algorithms we've seen. So these are more for high level questions. For example, do I go in 2 production lines? Do I go in 3 production lines? If you are testing different flexibilities of your operations. The advantage is that you can really go into as much detail as you want. You can try to really model your whole production line within the simulation and really catching all the features that that are important to determine the best schedule. All right, so that was a very short introduction in advanced scheduling. So now that we all have a common understanding, so to say, of what it is all about, I leave the word to Piero to introduce how we as a FESO implemented it at one of our clients.
Thank you, Thomas. So this example I'm bringing to you is a client, top class world leader in ceramic and pot manufacturing. You may remember during COVID lockdown that we were all trying to find new ways to spend our best time at home. So some people started cooking, other people maybe singing at the balcony, but many of us started gardening actually. And all of a sudden, our client began to have issues to respond to such a huge and unexpected spike in demand. And it was practically impossible to manage an increase of production capacity so quick. So they started to externalize a large part of the production to third-party suppliers, leading to a large erosion of margin, of course, compared to period before COVID. One of the reasons of this difficulty is, as often happen, the complex production process, mainly in this case an effect of many different SKUs, more than 10,000, with varying characteristics. You may imagine vases, which are large and small, of different shapes and colors and weights and materials. So therefore, a lot of production constraints arise because all these SKUs undergoes different production processes. And as often happened, there was not a good digital system to face this complexity, and the production is very customized. So the knowledge is concentrated on very few individuals, and therefore everything is basically done by hand, manually through Excel. The problem is that there are typically too many possible ways and options to modify the production process. For instance, you can simply decide, I don't know, to buy new equipment, and it's not easy to understand exactly how this impacts production overall. It's difficult to know in advance if you need more FTEs, for example, at the line to avoid oversaturation, how many, where exactly are the bottlenecks, or how much I should supply, how will the OE remain the same, what will be my average lead time. So there are many questions, many valid questions, but the answer is typically hard to find because it requires a lot of complex thinking and sometimes expensive trials. If we look at a traditional approach, I can say you may want to go for a trial and error schema, for example, guided by domain knowledge, but this is usually risky because it takes time and effort. You can use simple tools like Excel, but most of the fact remain hidden because not because Excel is a bad tool per se, but because it's not meant to capture the complex dynamics of a system, the variability. So even existing planning systems sometimes are not able to do it because the optimal plan, in my view, remains steady for a very short amount of time. So the variation of mix and demand, new product, new processes, leads inevitably to degrade these plans very quickly. So we need to shift from an approach like a click and run, if you want to say, towards a paradigm which is more continuous and dynamic, exactly like a digital twin and optimization solution like the one we are showing you. So what is that? Is basically a simulated copy of your processes, pretty accurate, which you can use to perform optimal multi-scenario analysis, evaluate the effect of modifications, evaluate bottlenecks, KPIs, extract basically all the data that you need in much less time with much less risk. So digital twin coupled with AI optimization provide the best way nowadays to achieve an optimal planning and scheduling in a dynamic environment. You can see here a simplified high-level schema of the production process in the plant. You can also understand how much more detail you may need to capture, but this is not actually a time-consuming process, because if you know what to look for, which data to gather, and how to build this is actually a straightforward task. So once the digital twin was in place at our client, we could obtain a long list of benefits. First of all, we could analyze the process in detail. So, for example, one positive side effect was being able to measure the impact of losses on production capacity. But also we use the digital twin as a basis, of course, for production planning, as we said, and able to prove that it's possible to achieve up to 60% of production increase without investing additional CapEx, which also means, for example, in this case, that we could suggest our client to avoid spending money in a new press, which costed at the time around 500,000 euros. Last but not least, I think you can use the system overall as an operational tool, not only as a strategic tool, but also as an operational tool. So we can deliver this to the customer. They are using it day by day in their job, saving an immense amount of time, non-value at the time for other more interesting operations. So we, as I said, one benefit could be to analyze the process more in detail. And for example, what you can say through a digital twin is you can analyze the impact of each losses and each waste, for example, on the production capacity. These as a twofold effect. So first is to guide them the improvement actions. So you can focus on what matters most. The second is also to be able to prove what you can achieve without those losses. So as I said, it can be used as a strategic tool and for decision making. However, as I said, this was not only the only say analysis we've done, but we could also analyze the bottlenecks, the situation, of course, the production planning effect, and also go into the root causes of these stops. So, for example, one of the main issues we found was related to the way actually you plan products in the presses on a daily basis. Not because this is directly related to the presses, but because this is related indirectly to the efficiency of the subsequent drying process. So in fact, after pressing, the bases are brought are collected on a plate and pushed into a dryer. And there are many, up to 12 levels in the dryer. So you can dry many different SKUs at the same time. And you can understand actually how different SKUs requires different settings. And the two are very much tightly related to each other. And it's very complex to find the best setup, the best combination of plan and settings at the same time by hand. So what we did was devising and implementing a custom AI algorithm for scheduling based on the digital twin. And we were able to achieve up to 6.87% increase in production capacity. Again, at no cost, in a way. I would like to stress the point that the digital twin is fundamental in this process, because the reason is that we are not performing optimization on part of the production press and dryer in isolation. We focus on that, but the optimization targets the overall production process. So we are simulating the overall production process in order to understand the effect on the overall set of operations. So we discovered, for example, that the maximum increase possible in throughput in a condition where you have a lot of losses is 1.5% and can go up to 6 and 7% if those are removed. But the good thing is that the digital twin is dynamic, so the optimization adapts and follow and find the best solution under varying conditions. Of course, it's not just a matter of finding daily optimal plans. If you in the next slides, we can see that basically the most benefit that can be achieved by considering the overall weekly and monthly plans. So in a complex system, the way you plan long and mid-term definitely impact also the short-term planning and of course production capacity. So in our case, started from a demand and a long list of SKUs, requested amount, delivery dates, stocks, supply availability. There were billions of possible production plans that you can do, a combination to be chosen from. And in addition, we also have to take into account dozens of different possible constraints. So not all those plans are feasible, but still, this is not reducing the number overall significantly, but is actually increasing the complexity of finding an optimal solution. Doing this by hand is absolutely impossible in an optimal way. Still, the plans are very good, I can say, but finding those optimal plan is hard, very hard. So again, using the digital twin as a basis, we could create an algorithm ad hoc for that to select and suggest the best plan across all those billion of feasible plans, using throughput and OTIF in this case as a target. Please consider that. So in this case, we could achieve, I would say, 10% on average capacity increase. On average means that sometimes certain weeks you have more, certain weeks you have less, but on average, this is the result we get. It's also important to note that we can have not only that as a target, but potentially more targets we can define depending on the situation. If we are targeting OTIF only, if we are targeting saturation, if we are targeting all of them, okay? So it's pretty flexible in the way we can set up our target. And also another point I would like to stress is that we put a lot of effort in making this fast, because most of the time the bottlenecks of this solution is that it requires a night to run. And there are ways actually, as we saw before, to avoid to evaluate all the solution and go for only the most promising and optimal solution first. So to conclude, we were able to basically provide, and that's the final slide, is this as a tool to our clients. So it's not only, as I said at the beginning, a strategic solution. It's also, it becomes an operational tool. So we could deliver this to our client, tailor it exactly for the scope. So you can get, through a very simplified interface, you can get the optimal plan on a weekly basis, on a daily basis. You can use it to forecast capacity, because if demand changes over time, you can understand through this tool how many FTEs you have to allocate, for example, to each of the station and the lines. You can basically avoid to spend time and effort on Excel-based analysis, and potentially you can even test new scenarios. So eventually you can use the same basis to extend it and analyze if, for example, you really are convinced to buy new equipment. Before to do that, having a digital twin like this, plus the optimization engine, is paramount to understand if this is worthy or not. So I think this is basically, in a nutshell, one single case. Of course, we've done it in many more environment and scenarios, but I stop here because I think it would be good to have a round table of eventually questions, and if we can answer, it would be great.
Maybe to conclude, we go over the key success factors that we notice from doing such projects. So first one is really to, as an advice, master and standardize your processes as much as possible. This will allow you to model or to capture your process as good as possible in this optimization of your scheduling. If you don't know what's happening, the model will not know either. The second thing is, as you've seen from Piero's presentation, is that combining these efforts of advanced scheduling with an operational excellence will really allow you to get the most result out of it. So we've seen that without operational excellence, without reduction of the losses, you could only win 1.5% in that case. Boosting it through reduction of losses, it goes to 6.8, I think it was. Third is to having access to real-time data will allow you to react and to steer much quicker in your schedule. So really knowing digitally what's happening in your production process will allow, again, the scheduling optimization to run smoother. Fourthly is to monitor your process, and with that we mean either with a digital control tower, so managing your KPIs in a visual dashboard, or having a well-defined PCS structure will allow you again to not be surprised by disruptions, and again to be able to spot changes quicker and adapt them in your schedule. It's also a good point to note that advanced scheduling is not there to replace people, it's there to assist people. So involving your people with the tool, it's helping them to make decisions and to spend their time doing more important things than running 10 million scenarios in their head. It's a decision-making assistance tool. It's not a replacement tool. And lastly is to really collaborate between the different departments to really find an optimum that's the best for your whole supply chain, not only for one silo within the production process, but to have all the chains interconnected also in the scheduling tool will really help you to get the most wins out of it. Good. That brings us to the end of the webinar. If you have any questions, feel free to ask them in the chat box. Piero and I will try to answer them. I don't think we have gotten any questions so far. So Andreas asks, how long did it take to realize the solution? Piero, maybe you can answer to that one.
Yes, overall, in this case, it took 4 months. Most of the time was spent actually understanding the process and analyzing the process first, working with the people at the plant, and then building the solution and gathering the results was pretty fast, I would say. So overall, 4 months.
Max asks, what data would you typically need to implement an advanced scheduling solution? Maybe I can tackle that. So you really have to think of what do your schedulers need to know to schedule your production, and that's typically what are the orders? So what do we need to make? How much by when? So delivery dates or required delivery dates. Details of production. So how does your production line look like? Which machines are there? At what capacity can they run? At what speeds? And then really the constraints. So getting as much data on how your production process works. For example, if there are certain products that cannot follow each other, these type of information need to be included to have a correct model. It's, Luco asks, how do you select the right implementation partner, or better, the right software? Maybe Piero, from your experience.
Well, yes, exactly. So their answer is from experience, I guess. The right software depends on the context, on the type of problem you have to face, the type of constraints, the type of data you don't have. So typically choosing a framework or software or a specific solution is a matter of analyzing the context, and through our experience we can guide towards the best solution. For the partners, of course, I mean, that's I would say, we can do the partners, but then of course choosing the right partners is never easy, and so I don't have a very good answer for that.
All right, thanks. I have a question. What is the digital tool recommended for chemical industrial company? I think there it will depend on the problem you're trying to face. So how does your production line look like? How many different constraints and goals are you trying to optimize? So if you're asking which algorithm that we went over, I think in a chemical industry where you have many different recipe, so to say. Your constraints are growing and growing. So the first one, mathematical solution, will probably not be performant enough, and then it's really the question of what kind of what kind of schedule are you looking for? Is it really running over the 15 trillion different scenarios? Then again, we go to constraint programming. If you're combining it with other operational excellence efforts, like in the case that Piero presented, the digital twin will also give you a very good solution. Robin asks, can you combine production optimization and logistics in one advanced scheduling tool? I think yes. Piero, feel free to.
Yes, sure. I think it's not very typical, but we've done it in a couple of cases as well. And yes, it's just a more complex simulation in a way, because you have to extend it through across not only the production but also through scheduling. But the tool we suggest to use are suited for this kind of applications. So it's definitely more complex, because you need to gather more data. There are more systems to interact with, but it's absolutely possible. And it's not that this complexity comes also with more, say, effort in finding the solution. It's more effort basically in building the solution, but then you can actually get there very good results. I would even suggest it if possible, because as more end-to-end you can go, the better benefits you can probably achieve.
Yeah, exactly. Either you include it as a constraint to your schedule, or you make two optimizations and make sure they communicate. Does digital twin interface with SAP for master datas?
So interface might not be the right word. Most of the time, the interaction is that you need to gather data from ERP systems, SAP or whatever you have. And the digital twin can act also as potentially a repository of data that are more than what you have in SAP, because you have also to collect maybe other constraints that are not directly stored in the SAP at the moment. But there is no interaction in the sense of no conflicting interaction, because this is a tool that is typically built on top of existing system, works in a different environment. You can eventually, extract the result of that and put back into SAP, but this is a decision, so it's not mandatory. So the good thing is that typically there are many possible ways today to avoid, interference between the two systems, but you need the data for sure.
Thanks. I have another question from Bart. What about scenarios between supply of different customers or products as input to overall expected profitability? How could that be captured? I have to read the question one more time. That's a good question. I think, yeah, within a digital twin solution, for example, you give an example. Yeah.
Okay.
So,
I don't know if you want to, but maybe, I'm not sure, but maybe if you think about connecting, for example, profitability of cash flow, this is also an interesting opportunity. We've done in one case, for example, being able to connect the solution to cash flow. So being able to optimize based on cash flow rather than profitability rather than operational KPIs. This has been done, and it's actually very powerful as long as you're able to connect the operation to cost and profits. I'm not sure if this is the question, but I guess this could be interesting anyway. And the last question is about how much it costs approximately to implement an advanced tool. Well, less than that amount.
good. All right. For the sake of time, I propose to end the webinar here. We would like to thank everybody for attending and for listening to our story about advanced scheduling. Should you have any more questions or any interest in a more detailed explanation, feel free to contact either me or Piero. You see the contact details on the screen. And we hope to see you in the next webinar. Thanks a lot.
Thank you very much.